Now let's have a look as to how trig and trig identities can be involved and applied into parametrics. So the same format of the question. So your question is going to follow the same format. You're still going to have to find a Cartesian, and then you're still probably going to have to sketch. Finding the Cartesian now is a little bit more complicated though, because of the fact that you got parametrics and because of the fact that you have trig. So I would say where right now each parametric is the subject of the formula is x and y, you want to change that up and make the subject sine t and cos t. So can you try that for me, please? So if you're trying to make sine t the subject, you just have to take this 2 to the other side, x minus 2. And to get cos t, you move the 3 to the other side, y plus 3. Okay. Your Cartesian involves squares, like this. So this is going to be your sine, this is going to be your cos. And then it equals 1. So do you see where I'm going with this? Sine squared cos squared equals 1. That's your identity. Yeah? So you're going to make use of this. And now when you substitute, you have this. That's your Cartesian. Now, when it comes to sketching the curve, this isn't really a curve. It's a circle where your radius is 1 and your center is 2 minus 3. So draw axis. 2 minus 3, I'm going to say, is somewhere here. And ideally the same radius, but you can just label that as 1. And then there you go. That's it. Done. Okay. This question. If you feel comfortable enough, you can try this on your own. If not, I'm going to go through this one and then you're definitely going to do the next one on your own. So, you want to find the Cartesian. They haven't really given you any indication as to what the Cartesian could look like, unlike the question before. So in this one, you're kind of guessing a little bit, but not really. For part A, your y parametric involves sine 2t. And there's only one formula you can use for sine 2t. That's your double angle formula, right? When you use your double angle formula, you get this. Okay? And now you know that x equals sine. When you sub that in, you get this. Okay, that's still not finished though. You still have a cos there, which you don't want. Your Cartesian has to be all x's and y's. So, what can you do from here, do you think? Well, let's take sine squared plus cos squared equals 1. And let's rearrange that for cos t. What would you get when you rearrange that for cos t? You would get, if I take it step by step, 1 minus sine squared. And then this would be the square root of 1 minus sine squared. Now we know that sine is x. So sine squared would therefore be x squared. So cos t is 1 minus x squared, all rooted. What you can now do is plug that into your equation. So y equals 2x root 1 minus x squared. And that is your Cartesian. Okay, now you need to find the values of k. They've given you the values of t, so the range of values that t can take. You need to find the range of values that x can take. So you're going to plug in your two extremes for t into x. Sine minus pi over 2 and sine pi over 2, which gives you minus 1 and 1. So this Cartesian is valid when x is between minus 1 and 1. Okay? Cool. It says write down the range. Okay? How would you do that? Well, with this range of values for t, the minimum and maximum for sine 2t is minus 1 and 1. So minus 1, y 1. There you go. Nice and easy. Okay, this question. Can you do that on your own, please? So the same thing as before. You're going to make cot the subject of the formula. You're going to make cosec squared the subject. So x minus 2 equals cot t. And y plus 2 equals cosec squared t. Now, I'm going to use the identity 1 plus cot squared is cosec squared. And now I'm going to sub in my substitutes. 1 plus x minus 2 all squared is y plus 2. And now it's just a matter of expand and simplify. So 1 plus x squared minus 4x plus 4 is y plus 2. So y eventually equals x squared minus 4x plus 3. Okay. The range of x when t is between 0 and pi is all the real numbers. So in this case, the domain is x can be any real number. Okay. Part B is just a sketch. So we take our Cartesian and we factorize. We want to make double brackets. We want to make equal 0. So what do we get when we do that? X minus 3, x minus 1, x equals 3, x equals 1. Those are the two roots. What would the minimum point be? Two minus 1, which you should get after completing the square. And then the y-intercept would be what? 3. After substituting x equals 0. Now that you have all your information, it's going to look something like this, where this point is 3, that's 1, that's 3 as well, and then this point is 2 minus 1. There you go, that's your sketch. And that is how you make use of trig with parametrics.